Hello friends, how are you? I hope that you all are well. Today in this video I am going to explain the reflection of light. Just it is the continuation of the previous video introduction. In last video I explained about the two laws of reflection. According to first law of reflection, the incident ray, reflected ray and the normal, all three lie in one place. And according to the second law of reflection, I explained the angle of incident and angle of reflection both are equal. The surface, whatever it may be plain surface or it may be rough surface, does not matter. But in all cases, the angle of incidence equal to angle of reflection. This was the matter I explained in my previous video. So today I would like to say about the regular and diffuse reflection. So what is regular and diffuse reflection? So what is regular reflection? Now you see, suppose this is the surface of a plane mirror. This oblique represents back side of the plane mirror. In this case, suppose a parallel beam of light rays in the sense a group of light rays. Those are parallel beam of light rays. Now they are incident on the smooth surface. After incident, they are reflecting. That means they are going back into the same medium. That means they are reflecting. The incident ray are reflecting by making both angle of incident and angle of reflection equal. That is the laws of reflection. Means say, suppose at this point if I draw the normal, all the rays are following the laws of reflection. That means here the rays are coming parallel and they are also reflecting parallel. So this is possible in case of the smooth or plane surface. Because here the face of the surface or every point on the surface of the plane mirror facing in one direction. That's why how they are coming, they are also going like that. Means angle of incident and angle of reflection both are equal. And due to plane mirror, the parallel rays, they are also reflecting in parallel. That means here incident rays are parallel, reflected rays also parallel. Parallel rays of light makes the image. You see that in mirror we see the image of our face. Why? Because on the surface of the mirror regular reflection takes place. So regular reflection able to make the image. Suppose in case of the cinema hall, the light coming from the projector, they also make real image on the screen. That is also example of a regular reflection. But if the surface is not smooth or if the surface is rough, in that case, suppose a piece of paper, it looks like plain, it looks like smooth, but if you see it with the high power microscope, you will find that the surface of the paper is not smooth like mirror. It is rough surface. So in these rough surfaces, for example, the surface is rough surfaces. Now, a beam of light, a group of parallel rays of light, after incident, they reflect, but they reflect in different directions. How they are coming parallel? When they reflect, reflected rays here not parallel. It moves in different directions. So this type of reflection we say diffuse reflection, or we can say it is irregular reflection, or we can say this is scattering. You see that a book is on the table, we are in the room. At any point at the room, if you observe the book, we can observe it. How it is possible? Because the light which is falling on the surface of the book from any source, it may be your tube light, it may be sunlight, whatever it may be, the surface is scattering the light in all directions. That's why in which part of the room you look, the book will be appear. The thing is that the book is scattering the light. Here the reflection is irregular reflection, or we say diffuse reflection. Diffuse, or we can say it is scattering. So most of the objects what we observe in our surroundings, that surfaces are rough surfaces. So there irregular reflection takes place, scattering takes place. So the light rays falling on the rough surfaces, what scatters, it won't make image. Image formed on a smooth surface. It may be a plain mirror, or you can say that one steel plate which is very smooth surface. We can see our image. Even your mobile screen also, when it is off also, we can see the image because the surface is smooth. So regular reflection able to make the image. But irregular reflection does not make any image. So irregular reflection does not make image, but regular reflection makes image. Regular reflection makes image, but irregular reflection does not make any image. So one thing I would like to say, don't think that here there is a failure of a laws of reflection. In fact, there is no failure of laws of reflection. Here also angle of incident equal to angle of reflection. The fact is that in a smooth surface, all the particles facing in one direction, but here all particles are not facing in one direction. You see that, suppose this light rays, this is the incident, this is the normal, this is the normal. here it is obeying the law of reflection. Similarly, this one also following the law of reflection. Don't think that this is the flat smooth surface. Smooth surface means normal, it looks like 90°. But here actually all the particles on the surface, they are not facing in one direction. Here also we can take the normal, we can take the reflected ray. It is also following the laws of reflection. But the fact is that all the points are here not facing in one direction. If they face in one direction, then if I draw the normal, all normal will be parallel. But if I draw the normal here to that particular point, here all the normals will not be parallel, but it follows the laws of reflection. So whether it is the plane surface or it is the rough surface, everywhere the laws of reflection is applicable. Okay, so I hope that you are clear about the regular and irregular reflection or scattering. So regular reflection able to make the image, whereas the irregular reflection does not make any image, but it helps to see the object from different angles. I said that an object is on the table, from any side of the room you are able to see, because most of the objects, its surface is rough surfaces. Due to rough surfaces, it scatters the light in different directions. So from different angles we can see the object. Okay, but in case of the regular reflection, it is not possible. In case of regular reflection, if the light rays in which direction reflecting, in that direction if our position is there, it will enter in our eye and we will be able to see the object. Okay children, so in this topic some concepts are very important. I would like to clear that in this video. So one small concept is there, object and image. What is object and image? Listen carefully. Object and image, or you can say objects and image. What is object? What are objects and image? Objects means, see, anything what we can see, anything which gives out light. Objects means, see, anything which gives out light. Which gives out light means either it produces its own light or it reflects light coming from other sources. For example, you see sun, it gives its own light. So I can say sun is an object. Sun is an object. Suppose moon, it does not produce its own light, but it reflects the light coming from the sun. So I can say that moon is an object. So that's why I said that anything what you can see, we can say that is object. So clear? So I am telling the meaning of object in the aspect of optics or the light topic. Any words I am using, its meaning I am telling in the context of the topic, reflection of light or optics. So its meaning may be different places different, but the word meaning what I am saying, that is in the context of the topic light or optics. So anything what we can see, we will consider that is the object. In this topic, whenever we draw the ray diagram, we will use two types of objects. One is the point object, one is the extended object. This point object, extended object, will use one upward arrow mark. Throughout the topic, whenever we think about the object, it may be building, it may be a person, It may be a mountain, but all the time we'll use the upward arrow mark. That is the extended object or enlarged object. And another one will use the point object. Okay, how much small or big does not matter. It is the point object. So throughout the topic, we use two types of object. One is the point object, one is the extended object or enlarged object. Clear? So this is about the objects and image. Objects. Then what about the image? Image is nothing but a optical appearance. See here. Image is optical appearance. What optical appearance? When reflected light rays, light coming from a source falls on the surface of the object, and if it reflect like the surface, like smooth surface where the regular reflection will take place, if the reflected light rays either meet or appear to meet, then the image formation of image takes place. So the topic is about the reflection, so I am not telling anything about the refraction. In the refraction case also, image also possible. So image is formed when reflected light rays either meet or appear to meet. So image is formed when reflected light rays either meet or appear to meet. If they meet really, it will make real image. If it meets virtually or it appears like meeting, then it will make virtual image. So in this topic we will discuss about the real image as well as virtual image. So image formed when the reflected light rays either meet or appear to meet. If they meet, it makes the real image. If it appear to meet, it makes virtual image. Okay? So you remember that real image always inverted. See here. So real image is always inverted, vertically inverted. That means if the object is like that, image will be like this. This is about the real image. Okay? The image formed in our retina, that is also real image. Real image formed on a screen. So the image formed in our retina also real image, but we see the image of the object as well as, because our brain only make it as usual. Okay? So all real images are formed inverted. Okay? But what about the virtual image? Virtual image is erect. Virtual image is erect as it is. Okay? The image formed in a plane mirror is virtual image. It is laterally inverted. Laterally inverted means the left appear right, right appear left. Let us see how the image formed in a plane mirror. I said that when the reflected rays either meet or appear to meet, they make the image. So if they really meet, they will make the real image. If they appear to meet, they will make virtual image. Okay? So how the image formation takes place in a plane mirror. Formation of an image in a plane mirror. See here. Formation of image in a plane mirror. Let us see. Suppose XY is the plane mirror. This is the back side of the mirror. This is one point object. Okay? From this point object, light falls on the object. Okay? Again, after falling, it is reflecting. Now, suppose light from this object, it falls on this surface. This is the incident ray. Now, I can draw here one normal. Light rays follows the laws of reflection. That means this angle of incident, the light ray will reflect like this. This means the angle of incident and angle of reflection both are equal. From this object, point object, number of light rays are coming. But I need at least 2 light rays to get the image of the object, to draw the ray diagram. Suppose one more light rays coming like this. This is incident ray, this is the normal, this is the reflected ray. Okay? Now, this is the mirror, this is the object, your face is this side, light rays. Large number of light rays from this object after incident on the mirror reflecting. So, the reflected light rays, it enter in our eyes. But we feel that if I produce it, we feel that these light rays coming from this point. So this is the object, this is the image. O is the object, O dash is the image. This type of image is said to be virtual image. In fact, these 2 reflected light rays are not coming from this image, from this point. It seems that they are coming from that point. So, this image is called the virtual image. This is the formation of image in a plane mirror. This object I have taken point object. I have taken point object. If I join this one, you will find that here to here how much distance, here to here also that much distance. So object to mirror is called object distance. Object to mirror is called object distance. Mirror to image, this is called image distance. In a plane mirror, you will find that object distance and image distance both are equal, and the image all the time form behind the mirror. In fact, light rays, they never meet. It seems that they are diverging from this point. Okay, the light rays which enter in our eye, we feel that they are diverging from, they are coming from the point O dash. So O dash is the position of the image, or you can say image of this pointed object. Okay, so this is about the image formation in a plane mirror. Okay, or image of pointed object in a plane mirror. Now let us see about the extended object. So formation of a image of an extended object on a plane mirror. On a plane mirror. Now let us see. Suppose this is the plane mirror. This is the plane mirror. In its front, I have taken one extended object. Okay. Suppose OB is the object. Now, how its image permeates on the plane mirror? From this point, I am taking one ray. This is the incident ray. I can draw, this is the normal, this is the reflected ray. Okay? Now, again, I am taking one more incident ray from this point. But this incident ray, how I am taking? It is making 90 degree with the plane mirror. That means here incident ray and the normal both are only appearing one, because this ray is incident perpendicularly to the surface. That means which one is the incident ray? That is only normal. That means angle of incident is 0. Angle of reflection also 0. That means how the light ray will go, it will also return along the same path but in opposite direction. Okay, this is the incident ray, this is only reflected ray. So this is another reflected ray. Now I am extending it, I am producing it. Okay, so this is the incident, this is only reflected. Okay, suppose this is the C. This B, this is the image of a B, B dash. Similarly, from one more point, if I take, this is the incident, this is the normal, this is the reflected ray. One more ray I shall take. Suppose I am taking it normal, perpendicular. This is incident ray, this is only reflected ray. Okay, now I am producing it. Okay, see that this is the O dash. That means O dash B dash is the image of the object OB. So one more information I would like to say that if any light ray incident on a surface perpendicularly, that means it makes angle of incident 0 degree. So the reflected light also will travel along the same path but in opposite direction. That means if this is the mirror, this is the incident ray, this is only will be the reflected ray. Okay, both are coincide. Okay, so incident and reflected. So this is the object, this is the image. And in plane mirror, the image of an extended object, you will find it is laterally inverted. So here the image permeate, the characteristics of the image permeate in a plane mirror. What are the characteristics? So characteristics of image format in a plane mirror. First point what? First point is that image is virtual. Second point is erect, means standing. Here arrow mark upwards, here is also arrow mark. Third point, it is the same size. What is the size of the object? That is only size of the image. Size of the object, size of the image. Fourth point, laterally inverted. Laterally inverted. Okay. Fifth point, object distance equal to image distance. These are the characteristics of the image formed in a plane mirror. So it is the virtual, not the real image. It is erect as it is. So in a plane mirror, when you are standing, it looks like standing only because the image is erect. It is the same size. What is the size of the object? Size of the image will be same. Laterally inverted. Laterally inverted means the left side of the object in the image, it will appear right side. Right side of the object in image, it will appear left side. Suppose you are standing in front of a plane mirror. You are raising your left hand, but for you it will appear right hand. If you raise the right hand, it will appear left hand. Why it is happening? Can you say? You see that, for example, this is the plane mirror. This is your ear. This is your right ear. Light came from this ear. Light came this way. But going time it is going in another way. So, for your eye, it will appear that coming from this side, not from the left, from the right. Or if it is right ear, for you it will looks like a left ear. Okay, that is due to lateral inversion. Left appear right, right appear left. It happens in case of the virtual image. In case of the real image, that is the vertically inverted. So this is not vertically inverted. This is just laterally inverted. So suppose this arrow mark in a plane mirror, how it looks? It looks like arrow only because it's left and right, both sides are identical, same, similar. But if I write like this, in mirror it will appear like this, just opposite. If I write 2 in mirror, it will appear like this. Okay, this is due to lateral inversion. So the image formed in a plane mirror is laterally inverted. So this is about the formation of a image, whether point object or extended object, or you can say enlarged object in a plane mirror. And I hope that you also know the uses of a plane mirror. Generally, plane mirror, we say it is looking glass. That means we used it as a mirror. Sweet stalls, they also arrange the plane mirror parallel to get the multiple images. Okay, in the general salons also we are finding also plane mirrors. Okay, so these are the some of the applications of a plane mirror. So children, I would like to say that in this reflection of light, specially we will study about the reflection in spherical mirrors. That means concave mirrors and convex mirrors. So in my next video, I shall discuss about the reflection of light in spherical mirror. So in that video, I shall give the details, concept about the spherical mirror. Thereafter, how the image formation takes place, we'll discuss in the next video. I hope that you might have subscribed my channel. If you have not done, you do it for getting the information as early as possible. At the same time, don't forget to share this video with your friends. As a result, they can also get the benefit. So until the next video, bye. Thank you.